Hello everybody. Today we'll be discussing about the primary metabolites belonging to the class of carbohydrates. The examples as per the PCI syllabus are Acacia, Tragacanth, Agar and honey. So let's have a look on to the first carbohydrate, that is Acacia. The primary metabolite obtained from carbohydrates is Acacia. Its synonym is Indian gum, gum arabic, gum acacia. Coming to its biological source, it is the dried gummy exudate obtained from the stems and branches of Acacia arabica wild, belonging to the family Leguminaceae. Coming to its geographical source, this plant is found in India, Sri Lanka, Sudan, Morocco, and Africa. In India, it is found chiefly in Punjab, Rajasthan, Western Ghats. About 85% world supply of this gum is from Sudan. Coming to its cultivation and collection. It is commonly found in dry monsoon forest of India. It is an evergreen tree with short trunk, not cultivated on commercial scale. That's why it is called as wild, the species wild. Gum is collected from wild grown plants made free from bark and foreign organic matter, dried in sun, which also results in partial bleaching of the gum. Next, coming to its color. The tears are cream brown to red in color, while the powder is light brown in color. Means the acacia gum appears like the tear form. And coming to its odor, it is odorless, and the taste is bland, nothing but mild or tasteless, and it is mucilaginous. Coming to its size and shape, it shows irregular brown tears of varying sizes. Coming to its extra features, the tears are glossy, nothing but shining, marked with minute fissures. Fissures are nothing but splittenings and are brittle in nature. Pieces of broken tears are with angular fragments and glistering surfaces, breaking with difficulty. Coming to its solubility, it is soluble in water. Watery solution is viscous and acidic, whereas insoluble in alcohol. Coming to its standard, it should contain not more than 15% of moisture and 5% of ash, and should not contain tannin, starch, and dextrin. Coming to its chemical constituents, acacia consists principally of araben, which is a complex mixture of calcium, magnesium, potassium salts of arabic acid. Arabic acid on hydrolysis gives L-arabinose, D-galactose, D-glucouronic acid, and L-rhamnose. It also contains enzymes such as oxidases, peroxidases, and pectinases. Next, the chemical test. Chemical test. So first one is lead acetate test. The solution of lead acetate gelatinizes the aqueous solution of Indian gum. So here, when the solution of lead acetate is mixed with the solution of Indian gum, a gelatinous product is formed. The other test is it does not produce pink color with the ruthenium red solution. And the third chemical test is on addition of hydrogen peroxide and benzidine in alcohol to aqueous solution of gum leads to the formation of blue color. It is due to the presence of oxidase enzyme. Next, coming to the uses. Acacia is a demulcent. What do you mean by demulcent? Demulcent is nothing but soothing substance. Next use is in the form of mucilage. It is used as suspending agent. It is used as emulsifying agent for fixed oils, volatile oils, and liquid paraffin. It is a good binding agent for tablets, pastils, and lozenges. It is used in the process of granulation for the manufacture of tablets. It is a gum of choice as it is compatible with other plant hydrocolloids as well as starches, carbohydrates, and proteins. It is used in combination with gelatin to form conservates for microencapsulation of drugs. Means it preserves the uh, or else it will enhance the stability period of microcapsules when it is mixed with the formulation. Next, coming to the substitutes and adulterants of acacia. The British pharmacopoeia variety consists of gum obtained from Acacia senegal white, a plant of African origin. Here the tears are rounded or ovoid, 5 to 40 mm in diameter, yellowish white in color. It is used as substitute to our Indian gum. The other adulterant is gum ghati, which is derived from Anogenesis latifolia, belonging to the family Combretaceae. Its outer surface is dull and free from fissures. Starch, Tragacanth, dextrin, and sterculia gum are the other adulterants of acacia. Coming to its storage, acacia or powdered acacia should be stored in cool dry place in airtight containers. Our next carbohydrate is agar. The synonym is agar agar or Japanese isinglass or vegetable gelatin. These are the other names for agar. Coming to its biological source, it is the dry gelatinous substance obtained from Gelidium amansi, belonging to the family Gelidaceae, and other species of red algae like Gracilaria belong to family Glaceriaceae, and Pterocladia belonging to the family Gelidaceae. Coming to its geographical source, agar is produced commercially in Japan, Australia, New Zealand, USA, and India. It is produced in coastal regions of Bay of Bengal also. Coming to its preparation, in Japan, the red algae is grown on the bamboos spread in ocean. The collection of the material is done in the month of May and October. The seaweeds are scraped from the bamboos. Later on, it is dried and shaken. This is necessary to bleach the product to some extent and even to remove foreign materials like shells, sand, etc. The entire material is then taken to the high altitudes where it is washed and bleached by exposing to sun. Later on, it is boiled for 5 to 6 hours with large quantity of dilute acidified water. That is about one part of algae with 60 part of water. It is boiled. Next, the extract is then strained, nothing but filtration. Strained while strained while hot through the cloth and transferred to wooden trough, nothing but containers wood, made up of wood. On cooling, jelly is produced. These rectangular solid pieces of jelly are then passed through the netting under pressure. Again, here also straining material, which is nothing but the net. Narrow strips thus formed are allowed to melt during the daytime in the sun, which removes the excess of water. This operation is continued for several days to remove the excess of water. The manufacture of agar takes place in the winter and moisture is removed by successively freezing, thawing, and drying at about 35 degrees Celsius. Japan is taking the advantage of natural climatic conditions since centuries for the preparation of agar. In America, the modern method of deep freezing is being utilized for the same purpose. Next, coming to its description or morphology. The color. Coming to its color, it is yellowish gray or white to nearly colorless, odorless. Coming to the taste, it is mucilaginous. Shape is found to be of various forms like strips, sheets, flakes, or coarse powder. The size of the sheets are 45 to 60 centimeter long and 10 to 15 centimeter wide. Bands are about 4 centimeter wide while strips are 4 mm in width. Strips are translucent, lustrous, and slender, while the flakes are grayish-white in color. In India, the raw material being used is known as Gallidiella acrosa, and indigenous production of agar is estimated to be about 200 tons. Okay, so in our country, in India, about 200 tons of agar is manufactured. In India, the process has been developed for the extraction of agar from the species of Hypnea. It is insoluble in cold water but forms a gelatinous mass in hot solution. It is soluble in boiling water and insoluble in organic solvents. Next, coming to its standards. So after performing the physical and chemical and biological evaluation, we will get these standards. And coming to the presence of acid insoluble ash. So here there should not be more than 1.0%, not more than 1.0%. Sulfated ash, not more than 5%. Foreign organic matter, not more than 1%. Loss on drying, LOD, not more than 18%. And starch. For testing the starch, you should get negative with iodine solution. So when it complies with all these standards, then we can say that our drug is pure, means free from any impurities. Next, about chemical constituents. Agar consists of two different polysaccharides known as agarose and agaropectin. Agarose is composed of D-galactose and 3,6-anhydro L-galactose units and is responsible for the gel property of agar. It contains 3.5% cellulose and 6% of nitrogen also. It is believed that it consists of sulfonated polysaccharide in which galactose and uronic acid are partly esterified with sulfuric acid. Agaropectin is responsible for the viscosity of agar solution. Next, coming to its identification test. For performing the identification test, you can follow three methods. The first one is boil about 1.5 grams of agar with 100 ml of water. Later on, you have to cool the solution to room temperature. It forms a stiff jelly. The other test is when mounted in the solution of ruthenium red. When you place this gel on the ruthenium red and examine under microscope, the mounted particles will give you pink color, will appear pink color. The third test is to 0.2% solution of agar in water. Means here 0.2 grams of agar dissolved in 100 ml of water. Add solution of tannic acid. When you add tannic acid, there won't be any formation of precipitate. Next, coming to its uses. Agar is used as an emulsifying agent and as a bulk laxative. So laxatives are especially useful in treating constipation. The next use is it is used in the preparation of jellies and confectionery items. So the confectionery items especially will have the sugar and syrupy or honey content. In microbiology, it is employed in the preparation of bacteriological culture medium. Next, our next primary metabolite is Tragacanth. So the synonym is gum Tragacanth, and the biological source is it is a dried gummy exudation obtained by incision from stems and branches of Astragalus gummifer label and other species of Astragalus family Leguminosae. Coming to its geographical source means in which places of the world it is available. It is indigenous or native to Iran, Greece, Turkey, Iraq, and Syria. In India, it is found wild in Kumaon. Kumaon is the place in Uttarakhand, nearby Garhwal region, central Punjab and Garhwal region, North Syria and Iran supply Persian Tragacanth. Coming to its cultivation collection directly, most of the shrubs from which Tragacanth is collected grow at an altitude of 1000 to 3000 meters. The mode of formation of Tragacanth is different from that of Acacia. Most of the drug comes from Persian source only. Coming to its morphology, the color is the flakes are white or pale yellowish white. Odor is odorless, mucilaginous taste, and coming to the shape and size, Tragacanth occurs in the form of ribbon or flakes, whereas Acacia appears in the form of tears. Here the shape is somewhat like ribbon or flakes. Flakes are approximately 25 by 12 by 2 mm in size, and the appearance of this Tragacanth gum is it is horny, translucent with transverse and longitudinal ridges. Fractures is short. Next, coming to its chemical constituents. Interestingly, Tragacanth comprises two important fractions. The first one being water soluble and is called as Tragacanthin, which constitutes about 30 to 40%, and the second being water insoluble and is known as Basorin. It constitutes about 60 to 70%. So maximum portion is Basorin, which is water insoluble. Both are not soluble in alcohol. Basorin actually gets swelled up in water. Why? Because it is insoluble in water and forms a gel, whereas Tragacanthine forms an instant colloidal solution. Next, 15% methoxy groups are present in Tragacanthine, which swells in water. The gums having higher methoxy content yields the most viscous mucilage. The product of hydrolysis of tragacanth are galactouronic acid, D-galactopyranose, L-arabinoramnose, and D-xylopyranase. Next, coming to its standards, the foreign organic matter not more than 1%, and the sulfated ash not more than 4%, and moisture content, it should not have more than 15%. So all these should be within the specified limits. Next, coming to its identification test. So these are the following three tests for or to identify tragacanth. The first test here, the solution of tragacanth when boiled with few drops of 10% aqueous ferric chloride, deep yellow precipitate is formed. The next test includes a stringy precipitate. A stringy precipitate is formed by dissolving tragacanth and precipitated copper oxide in concentrated ammonium hydroxide. Means a mucilaginous precipitate is formed by dissolving tragacanth and precipitated copper oxide. These two together you have to mix. Later on it is dissolved in concentrated ammonium hydroxide and you will get precipitate. Next is when it is warmed with sodium hydroxide solution, canary yellow color is developed. With strong iodine solution, it gives green color. Next, coming to its uses, it is used as a demulcent in cough and cold preparations and to manage diarrhea. As it is soothing, that's why it is used in cough and cold preparations. Next, it is used as an emollient in cosmetics. Tragacanth is used as thickening, suspending, and as an emulsifying agent. It is used along with Acacia as a suspending agent. Mucilage of Tragacanth is used as a binding agent in tablets and also as an excipient in pills. Tragacanth powder is used as an adhesive because of its binding properties. It is also used in lotions for external use and also in medically in spermicidal jellies. Next, it is also used as stabilizer for ice cream in 0.2 to 0.3% concentration and also in sauces, which retains its lifespan. Next, coming to the next primary metabolite, that is honey. So it is generally not obtained from plants, but it's a natural source. So coming to its synonyms, it is also called as madhu, mel, honey purified or purified honey. Coming to its biological source, Honey is a sugar secretion deposited in honeycomb by the bees Apis mellifera, Apis dorsata, and other species of Apis belonging to family Epidae and order Hymenoptera. Coming to its geographical source, it is produced in Africa, Australia, New Zealand, California, and India. Coming to its collection and preparation, so how the honey is produced, let's discuss that one. The nectar of the flowers is a watery solution containing 25% sucrose and 75% of water. It is the sucrose which attracts the honeybees towards the flowers. The worker bee sucks this nectar through its hollow tube of mouth, which is called as proboscis, and deposits in honey sac located in abdomen. So the worker bee, after sucking the nectar by using its mouth called as proboscis, it deposits the nectar in honey sac, which is present in the abdomen. Next, the enzyme invertase present in saliva of the bee converts nectar into invert sugar. Okay, this takes place in the saliva itself. Saliva. Uh, from the saliva, the invertase is produced, and later on, it will convert the nectar into invert sugar, which is partially utilized by the bee, and the remaining is deposited into honeycomb. Okay. Next is the honeycomb is smoked to remove the bees. So up to here, how it is produced, how the honey is developed. Now the next process is how you will collect the honey from the honeycomb. Now the honeycomb is smoked to remove the bees, and honey is obtained by applying the pressure to it, the pressure to comb, and allowing it to drain naturally. The honey of commerce is heated to 80 degrees, which is for supplying. It is heated for 80 degrees Celsius and allowed to stand. The impurities which float over the surface are skimmed off, means these are removed, and the liquid is diluted with water to produce honey of 1.35 density. Generally, the natural honey has the density of 1.47, which is more. That's why we are here for commercial scale. On the commercial scale, it is little bit diluted, and here the density is decreased. Many a time, honey is extracted from the comb by centrifugation. It must be free from substances. Honey is liable to fermentation unless it is suitably processed. If it is not processed properly, it will lead to undergo fermentations. Hence, honey has to be heated to 80 degrees before sending it to the market. This is to overcome fermentation. Later on, it should be cooled rapidly, or else what happens? It darkens in color on keeping. If necessary, honey is required to be filtered through wet cloth or funnel. When centrifugation method is not adopted, then you have to do this final step. Next, coming to its morphology. Coming to its color. It is pale yellow to reddish brown viscid fluid. Odor is pleasant and characteristic. The taste is sweet, slightly acrid. Coming to its extra features, the taste and odor of honey solely depends on the availability of surrounding flowers from which nectar is collected. On prolonged storage, it usually turns opaque and granular due to crystallization of dextrose. and is termed as granulated honey. So this type of honey is called as granulated honey because it is forming crystals due to the dextrose. Coming to its standard, the pure honey should should comply with these standards. That is, the weight per ml 1.35 grams. Coming to its specific rotation, so its optical activity. So it has the ability to rotate the light either to dextro, either to move clockwise or anti-clockwise. So the specific rotation is plus 3 degrees to minus 10 degrees. It will rotate the plane polarized light either in clockwise direction or else anti-clockwise direction. Next, the total ash content must be in the range of 0.1 to 0.8%. Coming to its solubility, it is soluble in water and insoluble in alcohol. It is a syrupy, thick liquid, translucent when fresh, and on keeping, it becomes opaque and granular due to crystallization of glucose. Next, coming to its chemical constituents. The average composition of honey is as follows. The moisture content is 14 to 24%, dextrose 23 to 36%, levulose, that is fructose 30 to 47%, sucrose 0.4 to 6%, dextrin and gums 0 to 7%, and ash 0.1 to 0.8%. Besides, it is found to contain small amounts of essential oil, beeswax, pollen grains, formic acid, acetic acid, succinic acid, maltose, dextrane, coloring pigments, vitamins, and an admixture of enzymes, for example, diastase, invertase, inulase. Interestingly, the sugar content in honey varies widely from one country to another, as it is exclusively governed by the source of the nectar, as it depends on the flowers, because here the honeybee sucks the nectar from different flowers, and the sucrose levels in different flowers may vary. That's why the taste also varies, and also the enzymatic activity solely controlling the conversion into honey. Next is chemical test. Chemical test. Adulteration in honey is determined by the following test. The first one is Fee's test for artificial invert sugar. So in some of the adulterants, the suppliers or the manufacturers may mix the artificial invert sugar, which appears like that of the natural honey. Here, for testing this, honey about 10 ml is shaken with petroleum or solvent ether, which is taken about 5 ml for about 5 to 10 minutes. So about 10 ml of honey is mixed with solvent ether, which is 5 ml, for about 5 to 10 minutes. After this, the upper ethereal layer is separated and evaporated in a china dish. On addition of 1% solution of resorcinol in HCl, a transient red color is formed in natural honey. Okay, so after evaporation of this ethereal layer, the resorcinol in HCl is added to this china dish. A red color is seen in case of natural honey. while in artificial honey, the color persists for some times. Okay, whereas in natural honey, it will disappear. The red color you will get, and after some time it will disappear. But whereas in artificial honey, the red color will persist for some more time. The next test is for reduction of Fehling solution. Here, to an aqueous solution of honey, about 2 ml, Fehling solution A and B are added, and the reaction mixture is heated on a steam bath for 5-10 minutes. A brick red color is produced to the presence of reducing sugar. The other test is limit test. The limit test for chloride, sulfates, and ash, that is 0.5%, are compared with the pharmacopoeial specifications. Next, coming to its uses. There are n number of uses, but here very few we have explained, which is sufficient for your syllabus. The first one is honey is used as a demulcent and sweetening agent. It is readily assimilated and means metabolized, and hence is a good nutrient to infants and patients. It is antiseptic and applied to burns and wounds. Coming to the next use is it is a common ingredient of several cough mixture, cough drops, and even it is a vehicle for Ayurvedic formulations because of its sweet taste, and even because of antiseptic properties in cough and cough mixtures it is used. It is used in the preparation of creams, lotions, soft drinks, and candies also. Thank you. Okay, let us view some pics of these primary metabolites. So this is a pic of Acacia gum. Okay. Next is the Agar. These are the plantation of Agar gel. Here, the barks are scrapped, and later on, ultimately, the gel is obtained. Next, this is the plant of Tragacanth, and here these are the gum, Tragacanth gum. Next, honey, as you know, these are the honeycombs. Inside these combs, you will find the honey. So these are the various types of primary metabolites belong to the class of carbohydrates. Thank you.